So sorry about that. I did cut off the first two there. So let me just quickly say them again. So the first question, f of x equal to e to the x plus 2 minus 3. The horizontal asymptote is y equal to -3 because it's shifted down by 3. Question B, the vertical asymptote is x equal to -5 because that's what makes the denominator equal to 0, and that's how we find vertical asymptotes. This function, or so this equation, this question, we're given f of x equal to log base 4 of x, g of x equal to 4 to the x, and we're asked for f of g of 3, and the answer is 3 because f of x and g of x are inverse functions. You can also show this work to show that g of 3 is 64, and f of g of 3 is f of 64, which is log base 4 of 64, which is 3. This question asks for the x-intercepts of f of x equal to x plus 3 squared times x minus 1 to the 5th. We're just seeing where this function ends up equaling 0, which is going to be when x is -3 and when x is +1. And then for the range of this function, f of x equal to x squared plus 1, it's a parabola shifted up 1. So we see that the lowest y value is 1. So our range could either be expressed as y greater than or equal to 1, or preferably the interval notation 1 to infinity. So sorry if you're watching the recording, sorry I didn't have it recorded before, but now we are recording, and I will get this posted later today. It won't be right away because I'm going to be on a flight until like 7 o'clock, but I will try to get it posted this evening. It is recording to the cloud, so I'm not going to be able to edit it really, but that should be all right. Also, apologies if you're having connection issues. I'm sorry about that. Hopefully it's not my fault, I don't think. Hopefully. All right, let's look at this next one. Domain of f of x equal to the 4th root of x minus 3. So if it's a 4th root, we know we have issues, right? We can't take an even root of a negative number. So when you see an even root, you should automatically say, okay, the insides, in this case, x minus 3, have to be greater than or equal to 0. And we can solve for x in this case because there's just one instance of x. That's x bigger than or equal to 3, or preferably everything from 3 to infinity. Of course, you're very welcome. Another inverse question function. If f of x and g of x are inverse functions and f of 2 equals 7, then g of 7 should equal 2. Now, you don't have to show any work, but if you want to show work, the work you could show is say, well, I know that g of f of 2, since they're inverse functions, that should be 2. But g of f of 2 is equal to g of 7. But we know that has to equal 2. Oh yeah, g of 7 has to be 2. Again, inverse functions interchange what x and y do. So if f and g are inverses, if that's your x and that's your y, then they interchange, and now that's your x and that's your y. All right. You got a question, don't hesitate to ask it. And you are welcome to unmute yourself, although I imagine people don't want to. You're also welcome to just type anything in the chat. All right, so now there's quite a bit of graphing on this exam, which is typical for the second exam of this class because we've talked a lot about graphing stuff. This first one says graph the following functions, indicating all important features, intercepts, asymptotes, etc. Also state the domain and range. So we've got log base 2 of x plus 1 minus 2. And I'm just going to write down for myself, that's going to shift left by 1 and down 2. So I know my new vertical asymptote, instead of being at x equal to 0, which would be typical for a logarithmic function, is now going to be left 1. It's going to be x equal to -1. So there's my new vertical asymptote. And I'm going to write it over here. Asymptote is x equal to -1. And then normally I probably wouldn't actually say, so normally, well, actually, I'm going to find the y-intercept because it happens to be given by this shifting, or sorry, well, no, it is the y-intercept. Normally there would be an x-intercept at 1. If that shifts left 1 and down 2, we're going to have a y-intercept at -2. Now we can also find that just the usual way we find the y-intercept, which is by setting x equal to 0. We set x equal to 0, we get f of 0 equal to log base 2 of 0 plus 1 minus 2. Log base 2 of 1 is equal to 0. Because 2 to the 0th power is equal to 1. So this is equal to 0 minus 2, which is -2. So my y-intercept is 0, -2. And I should graph it. I already graphed it. My x-intercept, we're going to get by setting the whole equation equal to 0, or y equal to 0. So we're going to set log base 2. I feel like I could zoom in a little bit. I feel like let's zoom in just a tiny bit more. I feel like it's kind of hard to see what. Yeah, that seems a little better there. Let me refocus. Okay, cool. So I'm going to set log base 2 of x plus 1 minus 2 equal to 0. When you're solving something like this, the first thing you want to do is isolate the logarithm. So log base 2 of x plus 1 equals positive 2, and then rewrite it as an exponential. So we're going to have 2 to the second power equals x plus 1. And then that's 4, and 4 minus 1 equals x. So the x-intercept is going to be 3. And then I know the general logarithmic function shape. It's going to go up like this. And as you get closer and closer to this vertical asymptote, the logarithmic function should go further and further down. And there should be a little arrow down here indicating that it keeps going down forever and ever. The domain of this, while we can see that we can't be 1 and we can't be -1 or smaller. So our domain is that x is greater than -1, or interval notation, everything from -1 to infinity. You could also have seen this by setting the insides of the logarithm, x plus 1, to be greater than 0, right? That's our usual domain restriction for a logarithmic function, is that the insides of the logarithm has to be strictly positive. The range, if we look at the graph, which is how we should often find the range of a function, we can see this goes, the y values go down to -infinity, and they also go up forever and ever and ever to positive infinity. So our range is literally everything. Great, that's the whole thing. Let's look at the next one. So now we've got a square root function. It's going to be shifted left by 4. It's going to be flipped vertically. And it's going to go up 1. So it's going to go left 4, and then it's going to go flip over, and then up 1. So I think what would have been at the origin is now moved over 4 and up 1. And it's going to go downward instead of upward. I'm still going to find all the normal things in the usual way. And I'm kind of in the way. Let me move this over here since I'm in the way of the page. So I'm going to find my y-intercept. Also, we should point out, we know this graph doesn't have any asymptotes, right? Square root functions don't have asymptotes. At least square root functions, they're just shifted or whatever. Like if it's more complicated, it could, but this function on its own does not. So we're going to set, one second, let me close the door. So we're going to set x equal to 0. We're going to get y equal to negative square root of 0 plus 4 plus 1. Square root of 2. So that's going to be a -2 plus 1, which is -1. So y-intercept is at -1. So that's a 0, -1 for my y-intercept. X-intercept is probably going to be somewhere between -4 and 0 because, right, from here to here, we cross the x-axis. So if I set the whole thing equal to 0, I'm going to get 0 equal to the negative square root of x plus 4 plus 1. And my way of solving this would be to add the square root of x plus 4 to both sides. So I'm going to have the square root of x plus 4 equal to 1. Square both sides. You get x plus 4 equal to 1 squared, which is still 1. And then subtract 4, you get x equal to 1 minus 4, which is -3. So right there. And then I'm going to graph it. So I'm starting here, and instead of going up to the right like a square function usually would, it's going to go down to the right like this. The domain, well, we know that x plus 4 had to be greater than or equal to 0. So we get x greater than or equal to -4, or -4 with a bracket to infinity. The range, well, again, looking at the graph, we can see that the highest y value is 1, and then all the y values are going to be smaller than that. So down, 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 all the way to -infinity. So my range is going to be y is less than or equal to 1, or -infinity up to 1 with a bracket. We do have a bracket because we are including that book there. All right, let's look at the next one. Simplify the difference quotient f of x plus h minus f of x all over h for the function f of x equal to 3x squared minus 6x plus 1. So it might help us to first write out that f of x plus h is just, instead of 3x squared minus 6x plus 1, it's 3 times x plus h squared minus 6 times x plus h plus 1. So now we're going to find f of x plus h minus f of x all over h. It's going to be all of that minus f of x, which is all of that. And we do need parentheses here. All divided by h. Now we need to simplify because our goal, our ultimate goal with this difference quotient is to make sure that that h cancels out. So I'm going to, let's say I have 3 times x plus h squared. You're going to see this a lot in calculus and the rest of math probably. X plus h squared, you should probably get used to seeing is x squared plus 2xh plus h squared. And then minus 6 times x plus h distributes, and you get a minus 6x minus 6h plus 1. And this minus sign distributes, so I get a minus 3x squared, a plus 6x, and a minus 1, all divided by h. And at this stage, I can cancel out a minus 6x with a plus 6x, and a plus 1 with a minus 1. But I can't cancel out the 3x. Oh, sorry, that's going to be a minus 3x squared. I can't cancel this minus 3x squared with this 3x squared yet because I haven't distributed 3 yet. So I have to distribute 3 before I can cancel. So I'm going to get 3x squared plus 6xh plus 3h squared. I'm distributing that 3 to each of those terms. And then I have a minus 6h still and a minus 3x squared. Now I can cancel the 3x squared with the minus 3x squared. And I'm left with a 6xh plus 3h squared minus 6h all over h. You can either just divide each thing by h and get 6x plus 3h minus 6. Or if you prefer, no, that's right. Yeah, sorry. Remember, I just thought I saw something. Or you can take an additional step if you want to and factor out an h from the numerator. Say if I factor out an h from here, I'm left with a 6x plus 3h minus 6 all divided by h. And then this h cancels with that h and we get that. All right, let's look at the next one. Find the vertical and horizontal asymptotes of f of x equal to 3x squared plus 19x minus 7 over x squared minus 6x plus 8. So the degrees are the same. So degrees, right, it's the degree 2 over degree 2, which means that the horizontal asymptote is going to be given by y equal to the quotient or fraction of the leading coefficients. The leading coefficient on the top is 3. The leading coefficient on the bottom is 1. So it's going to be y equal to 3 over 1, which is just y equal to 3. Vertical asymptotes we find by setting the denominator equal to 0. So we're going to set x squared minus 6x plus 8 equal to 0. And we're going to get x minus 4 times x minus 2 equal to 0. We're going to get x equal to 4 and x equal to 2. One small thing to be aware of, so if there are multiple powers of x in the function, do you look at the highest one on top and bottom? Yes, you do, exactly. So if, for example, this function had been something like, I don't know, f of x equal to 2x cubed plus 7x to the 4th over 3x plus 6x to the 4th, the degrees are the same. It's a 4th degree in the top and 4th degree in the bottom. And for this function, the horizontal asymptote would be y equal to 7 over 6. Even though it's written kind of in a non-standard way. We still have the same degree, and the fraction is the quotient of the leading coefficients. And the leading coefficient is just the coefficient of the thing that's x to the highest power. One other thing to be aware of, is that you don't get a vertical asymptote if that factor would have canceled. So like if this top part doesn't factor, but if instead, let me point out, let's say instead we had this, just for another example. Let's say our function was x squared minus 4 over x squared minus 6x plus 8. I'm going to point out that this factors as x minus 2 times x plus 2. And the bottom factors, like it did before, is x minus 4 times x minus 2. And I want to mention that this function does not have a vertical asymptote at 2, because the x minus 2 and the x minus 2 cancel. This function has a vertical asymptote at x equal to 4, and it has a hole at x equal to 2. Now that's usually a big deal, but it could come up on occasion, so I just seem like worth mentioning. So if you're looking for vertical asymptotes, you should factor and cancel any factors that cancel before you decide what your vertical asymptotes are. All right, so in this next one, we want to find the domain of f of x equal to the square root of x squared plus 4x minus 12 over x minus 7. Oh, sorry, you guys can see that. Sorry, the domain of f of x equal to the square root of x squared plus 4x minus 12 over x minus 7. This expression has two different things that we have to be aware of. So first and foremost, we want to exclude where x minus 7 is equal to 0, or x equal to 7. So whatever we get, we don't want 7. In fact, if I was doing my number line, I might even start off by being, okay, well, I know 7 is a no-go. So far, everything else is fine, but 7 is not okay. The second thing we have to be aware of is that the insides of the square root have to be greater than or equal to 0. So we need x squared plus 4x minus 12 to be greater than or equal to 0. This should factor. I'm not generally in the kind of person that's writing things that don't factor on exams. This factors as x plus 6 times x minus 2 bigger than or equal to 0. Now be careful. I saw a few of you do this on the homework. We can't just say that x plus, we can't write that each factor is bigger than 0. We can't say that x is bigger than -6 and x is bigger than 2. What we have to do is we have to use the number line and say, okay, well, in fact, I might have gotten ahead of myself by putting that 7 there. I'm going to kind of ignore the 7 for a minute. On the number line, I want x equal to -6 and x equal to +2, because those are the things that make this expression equal to 0. So here's -6, here's +2. And I'm ignoring the 7. I want to know where this whole thing is positive. So if I pick something like bigger than 2, you could pick 3 or 4 or 5 or 9. I'm not worried about the entire expression. I'm just worried about this. So whether I pick 3 or 5 or 9 or a billion, that choice plus 6 is positive, and that choice minus 2 is positive, right? 3 minus 2 is positive, 5 minus 2 is positive, 9 minus 2 is positive, a billion minus 2 is positive. So both parts are positive, and a positive times a positive is positive. So over here in this interval, the whole thing is positive. Between -6 and 2, we could and probably should pick 0. 0 is a great choice if it's in your interval. If we pick 0, 0 plus 6 is positive, 0 minus 2 is negative, and a positive times a negative is negative in this entire interval. We don't want it to be negative, so we're not going to include that in our final answer. Finally, if I pick something less than -6, like -8, -8 plus 6 is negative, -8 minus 2 is negative, and a negative multiplied by a negative is positive. I want the positive parts. So I want all of this. I want to include this endpoint because I want it to be greater than or equal to 0, and -6 makes it equal to 0. I don't want any of this, nothing between -6 and 2. I don't want -4. I don't want +1. Both of those make this negative, and we can't take the square root of a negative. But I do want everything from 2 onward, except I don't want that 7, because that 7 makes the denominator 0. So I want all of this, and I want all of this. You really want to write your answer here in interval notation. The domain is going to be, so I'm starting over here at -infinity, and I'm getting everything from -infinity to -6. Infinities always get parentheses. I want to include -6. I'm using a bracket. So that's everything here. And we're always going from left to right, which is why it's also good to write the number line so we can see what from left to right looks like. Now I want a union and then everything from here onward, but I don't want the 7, so I have to break it up as from bracket 2 to 7 with the parentheses. And then everything from 7 with the parentheses onward. All right, that's how you would write this one. Let's go ahead and move on and find the inverse of f of x equal to 2x plus 1 over x minus 3. I do tend to ask a question very similar to this on every exam because it does require a bit of work. So the first step is to write it as y equal to 2x plus 1 over x minus 3. Then we're going to interchange x and y. So we get x equal to 2y plus 1 over y minus 3. And then we have to actually do the work, or we're going to try and solve for y. The first step you're going to take in this kind of expression is to multiply both sides by the denominator. So you're going to have y minus 3 times x equals 2y plus 1 over y minus 3 times y minus 3. I don't think you need to show this step. I think it's perfectly fine to jump to, oh, I know the y minus 3's cancel. That's why we multiply by y minus 3. So I've got y minus 3 times x equal to 2y plus 1. Okay, be extra careful here. We can't just subtract 1 and divide by 2, because even though you would have y by itself, there would be a y in your answer. We have to distribute this x so that we can group all of the y terms on the same side to be able to solve for y. So distributing the x, I get x times y minus 3 times x equal to 2y plus 1. I'm going to group all of my y terms on the left side. So I'm going to get xy minus 2y, and I want all the not y terms on the other side. So I'm going to get this and this on the right. So I'm going to get a positive 3x plus 1. And then I'm going to factor out a y. That's why I brought all the terms that have just a y in it to, or I should say all the terms that have any y in it to one side. So I can factor or divide out a y and be left with y times x minus 2 equal to 3x plus 1. Then I'm going to divide by x minus 2 and get y equal to 3x plus 1 over x minus 2. And that is your inverse function. You don't have to like write it as f inverse, but I feel like I should. And I know this wasn't part of this question, but bonus question. Use this inverse function to find the range of f of x. So the range of f of x, well, the domain of this function is everything except for x can't be 2. So the range of my function is y can't be 2, which I could write very lazily like this, or more accurately as everything from negative infinity to 2, parentheses, union 2 to infinity. That would be the range of that function. Also, just a reminder, please do fill out the attendance form. Let me send it in the chat again. Or let me send it to everybody, not just. The only problem with when people chat with me regularly is then if I write back, it's not to everyone. There we go. Please do fill out the attendance form when you have a second. I know I haven't updated the attendance in a couple of days because I've been super busy. I will definitely try to get that updated over the week. I apologize for not having updated it, but I'll also correct anything. Also, attendance isn't part of your guys' grade, so it's not a huge deal if I don't get it right, although I do want to keep track of your attendance because that is how we get funded, is by how many students we serve. So please do fill it out, even though I said it wasn't that important. All right, so we're going to graph f of x equal to x minus 1 squared times x plus 3. I would usually start with the y-intercept just because that's what I would usually start with. So the y-intercept, I'm going to set x equal to 0, and we're going to get f of 0 equal to 0 minus 1 squared times 0 plus 3, which is negative 1 squared times 3, which is 1 times 3, which is 3. So my y-intercept is 0, 3. X-intercepts, I'm going to set the whole thing equal to 0. I'm probably going to do this work down here so I have enough room. Right? There's all this room here to use. You can definitely use it. So I'm going to get x equal to positive 1. I'm going to get x equal to negative 3. And then x equal to positive 1 has a multiplicity of 2. So we're going to bounce at 1. x equal to negative 3 has a multiplicity of 1. So we're going to cross at x equal to negative 3. So I mean, I don't really need to rewrite them here. I guess, no, I don't think you need to, but you could if you want to. 1, 0 is a bounce. And negative 3, 0 is a cross. And then just try and draw the graph as well as you can. It should be smooth. It shouldn't be pointy. There's no breaks. It's nice and continuous. So let's see, I've got the point 1, 0. I've got the point negative 3, 0. I've got the point 0, 3. Oh, I forgot about the end behavior. Let's talk about the end behavior for a second. You don't have to figure out the end behavior, but you can. So the end behavior is, well, the degree here is 3. Right? If you multiply the whole thing out, it's x squared times x, which is x to the third. And the leading coefficient is positive, which means it should be opposite directions, one up, one down. And it should be the left one is down, the right one is up. So I'm going to be starting low in quadrant 3. And I'm going to start, and I'm going to end high in quadrant 1. Right, I'm going to start down here. And I'm going to cross here and then go through this point and then bounce here. So here's the thing. When you draw this, it's not always super clear, like when you turn around, like, do I do like this and is this the top and then I go like that? Or do I go like above it and then come down towards it? It doesn't matter. Just try and draw it so it looks nice. You should refrain from using Desmos to help you draw it. It's okay if it looks not perfect. As long as it goes with your points and has the right behavior, I don't care. All right, let's see what this next one looks like. If f of x equals x squared minus x plus 5 and g of x equals 2x minus 1, simplify f of g of x. Okay. So f of g of x is going to be f of 2x minus 1. And then f of x is x squared minus x plus 5. Oh, can I explain how I found the endpoint? Yeah, so the end behavior. So here's what I was really thinking. So I said I saw it was an odd degree and a positive leading coefficient. So when I see that, I really think of y equals x cubed because that has the same sort of deal. So if I see degree being odd and the leading coefficient being positive, what the example I think of in my mind is, oh, well, one example of that is y equal to positive x cubed. And I know that looks like this, where it's down on the left and up on the right. So it starts low and it ends high. That's honestly what I'm thinking of when I think about it. Also, I'm remembering that when the degree is odd, I know it's going to be opposite signs. One side's up, or sorry, opposite directions. One side goes up, one side goes down. And when the leading coefficient is positive, eventually it gets very, very positive at the end. So in the beginning, it has to start very, very negative. You need to make the coordinates clear. So I feel like this is totally 100% clear, right? I definitely have labeled, I've indicated what my x and y intercepts are, and I made little marks that show like, oh yeah, that's -1, -2, -3. I don't think you need to actually write those numbers down there unless you're using a different scale. So I think this would be perfectly fine. I don't think you want to write in the coordinates. We'll see one exception to that when we talk about the piecewise graphing function. That's a little bit simple. So for this one, no, you only have to indicate the intercepts, and that can just be done by showing where they are on the axes. For f of g of x equal to f of 2x minus 1, we're now going to say, well, f of x is x squared minus x plus 5. And then we're going to replace the x's with 2x minus 1. So we're going to get that squared minus that plus 5. But instead of it being x squared minus x plus 5, it's going to be 2x minus 1 squared minus 2x minus 1 plus 5. And then it does need to simplify it. So we're going to multiply it out. We're going to have 2x minus 1 squared, which is 2x minus 1 times 2x minus 1, minus 2x minus 1, distribute and get minus 2x plus 1 plus 5. When you multiply this out, you can do it the fast way and say it's the first thing squared plus 2 times the first and the second plus the second thing squared, or you can actually multiply that. 2x times 2x is 4x squared. 2x times -1 is minus 2x. -1 times 2x is minus 2x. Minus 1 times -1 is plus 1. And then I've got minus 2x, and 1 plus 5 is 6. This part, if you'd done it the fast way, would have been 4x squared minus 4x plus 1. And then we have a minus 2x plus 6. So we simplify, we get 4x squared. The minus 4x and the minus 2x becomes a minus 6x, and the 1 plus 6 becomes 7. If this factors, which I don't know if it does, there's no need to factor it. This is considered fully simplified. Don't bother trying to factor that if you're trying to simplify it. Let's look at the next one. Graph x squared plus 2x over x squared minus 4x plus 4. And we've been told that this factors on top as x times x plus 2, and on the bottom as x minus 2 quantity squared. That is a square. I know it's kind of hard to see those exponents on camera here. I'm going to start with the y-intercepts, even though they're way down here. So I'm going to set x equal to 0. And we're going to get y equal to 0 because f of 0 is going to be 0 times 0 plus 2 over 0 minus 2 squared. But the top is 0. So that's going to be 0 over 4, which is 0. So my y-intercept is just the origin 0, 0. Which means one of my x-intercepts is also going to be 0. And for the x-intercept, we're going to set the top equal to 0. Or the factored form would probably have been better. And we're going to get x equal to 0 with a multiplicity of 1. Not that we're being asked for the multiplicity, but I think it's worth noting. And x equal to -2, also with a multiplicity of 1. So both of these are going to cross the x-axis at those x-intercepts. Vertical asymptote, we're going to set the denominator equal to 0. And we're going to get x equal to +2. And I will point out that this vertical asymptote also has an even multiplicity. If the multiplicity is 2, it doesn't mean it's going to bounce, but it means it's going to stay on the same side of the x-axis. So either both sides are going to go up or both sides are going to go down. That's what happens when you have a vertical asymptote with even multiplicity. And then who can tell me what the horizontal asymptote is going to be? Well, I've got degree 2 on top. I've got degree 2 on the bottom. The degrees are the same. So I'm going to get y equal to, I really, really, really want to emphasize to everybody here. It's not y equal to 2 over 2. It's degree 2 on top, it's degree 2 on bottom, but what we're finding is it's y equal to the quotient of the leading coefficients, which is y equal to 1 over 1. So that's how we're getting y equal to 1 as our horizontal asymptote. And that's all the features. Now we just have to put it all together and graph it. So I've got my y-intercept at 0, 0. I've got my x-intercept at 0 and -2. I've got my vertical asymptote at +2. And I've got a horizontal asymptote at +1. This might be a good time for a sign chart because although we have all these points, we don't really know which way it's going. Or you could pick more points. So we make a sign chart that has the x-intercepts and the vertical asymptote. Basically, all the places where the sign could change. Let's just see what's happening over here to the right of 2. So if I pick a number larger than 2, like 3, I plug in 3, it's a positive times a positive times divided by a positive, which is positive. And then if I pick something between 0 and 2, like 1, it's a positive times a positive divided by a positive, because 1 minus 2 squared is still positive. If I pick something like -1, it's going to be a negative times a positive divided by a positive, which is going to be negative. If I pick something like -3, it's going to be a negative times a negative divided by a positive, which is positive. So we can kind of see, okay, it's going to be positive. It's going to cross at -2 and be negative. It's going to cross at 0 and be positive. It's going to go very, very big because there's a vertical asymptote at 2. And on the other side of that, it's also still going to be very, very big. So that's kind of the basic shape of our graph, not accounting for the horizontal asymptote. So let's see, it's going to do this kind of deal. And then it's going to go up like this. And then on the other side, it's going to go down like this. And then since there's nothing else to worry about, we're going to get closer and closer to the horizontal asymptote. And then on the left side, we're going to cross this point and we're going to get closer and closer to this horizontal asymptote. And that's it. You can definitely actually plot extra points if you want to, like you could have plotted x equal to 3 and 1 and -1 and -3, but it's not required. It does take more time to do that. So I'm just trying to show you what I think is the most efficient way of doing this. But if you want to plot more points to be sure of what your graph looks like, that's really, really okay. All right, let's look at this next graphing one, which is a piecewise function. So we're being asked to graph the following function: x plus 1 squared when x is less than or equal to 0, x minus 3 when x is between 0 and 4, and the absolute value of x minus 5 when x is greater than or equal to 4. And you have the option, although it's not required, to graph each piece on its own. So I'm going to do that real quick. So x plus 1 squared is the usual parabola shifted 1 to the left. So x plus 1 squared is going to look like this. And I'm only going to want everything to the left of 0. So I don't want any of this over here. I just want all this part right here. That's it. I want like all this part in red. Hopefully you guys can kind of see that. Not really. It's not great. I apologize. So we want that. And then for the line y equals x minus 3. Sorry, it's y equals x plus 1 squared. For y equals x minus 3, that's your line with an x-intercept, a y-intercept of -3 and an x-intercept of +3. So it looks like this. We only want between 0 and 4, so we only want from here to x equal to 4, which is here. So we just want that part there. And then we want the absolute value of x minus 5 for x greater than or equal to 4. The absolute value function looks like a V shape, and it's going to be shifted 5 to the right. So normally it'd be like this. Sorry, you guys can't see that. Apologies. Normally it'd be like this, but we're going to shift 1, 2, 3, 4, 5 to the right. So it would look like this. But we only want everything after 4. So we only want all of this part here. So the points that I think are going to be important to include on the graph, in addition to, sorry, down like that. You can see it. I can also zoom out a little bit. Sorry, hopefully that's good. So we definitely want to include the breakpoints. So this 0, 1 is important, in addition to being an intercept is important. So I know I want that point there, and then I want everything to the left like this. So look like that. And I'm going to include that point because I want the parabola when x is less than or equal to 0. So when x is 0, I'm going to get y equal to 1. So that point's filled in. For the line here between 0 and 4, I don't have the endpoint. So I don't actually get when x is 0. If x were 0, I would get the point 0, -3, which you might want to label, although I think it's pretty obvious since we've graphed it well. And then I'm going to go up and to the right. So I get to x equal to 4. But again, x doesn't actually get to equal 4, so I'm going to give myself an open circle there. But this other function, this other piece of that piecewise function, absolute value of x minus 5, if you plug in 4 to that, you do get 1. So even though it is an open circle here at the point 4, 1, I'm going to end up filling that in when I graph the absolute value part. All right, let's look at the next one. Oh, sorry, I've written all over this clearly. Apologies. Let me grab a blank piece of paper here. Let's see. Do I have a blank piece of paper somewhere? Sure, this will serve. The open circles, definitely. So we have an open circle here because we don't actually ever get the point 0, -3. If x were to be 0, 0 minus 3 would give us -3. But x can only be really, really close to 0. So like x could be, if x was like 0.01, well, that's between 0 and 4. And the y value would be, well, I'm going to use this piece of the function since x is between 0 and 4. The y value or the function value would be 0.01 minus 3, which is -2.99. So when the x values get very, very close to 0, the y values are getting very, very close to -3. We don't actually get the value of -3 because x, we can't plug in 0 here. We have to plug in 0 there. If this part's filled in, you can't also have this one being filled in because then you would have the function being defined to be two different values when x is equal to 0. But typically, the way I always think about it is when you have the strict inequalities, that's when you're going to get open circles. So x being strictly greater than 0, you get the open circle at 0, -3. And if this part hadn't filled this in magically over here, right, we would have had, when x is less than 4, we would have had the point, well, x would have been 4, 1, because 4 minus 3 is 1, but we don't actually get it. But then we do get it because this other function fills it in. Okay, let's look at the last question here, which is an extra credit question. We're graphing the following. It's going to have a slant asymptote. So we're going to graph, what do we got here? F of x equal to x squared minus 4x plus 4 over x minus 4. So let's find all the things. So y-intercept, and set x equal to 0. Oh, actually, you know what I should do before I even find anything? I should factor just to make sure I don't have anything canceling. So I'm going to factor this. This factors as the top factors is x minus 2 times x minus 2. And the bottom is just x minus 1. Okay. So finding the y, so nothing cancels. Just finding the y-intercept, I'm set x equal to 0. I'm going to get y equal to 0 minus 0 plus 4 over 0 minus 1, which is going to be -4. X-intercepts, we're going to set the top equal to 0. We're going to get x minus 2 squared equal to 0, which gives me x equal to 2, with the multiplicity of 2, which means we're going to bounce. Vertical asymptote, we're going to set the denominator equal to 0, and we're going to get x equal to 1. It does have an odd multiplicity, which means things are going to do the opposite. So either at your vertical asymptote, you're going to have the left side up and the right side down, or the opposite of that. You're going to have the left side down and the right side up. And then finally, there isn't a horizontal asymptote because the degree on top is larger. We do have a slant asymptote because the degree on top is exactly 1 larger. And to find the slant asymptote, we're going to have to do the polynomial division. So we're going to do x minus 1 into, you definitely don't want the factored form. You want the unfactored form, x squared minus 4x plus 4. What do we multiply by x to get x squared? X. X times x is x squared. X times minus 1 is minus x. Now be careful. I definitely saw people make this error on the homework assignment that I'm almost done grading. When you subtract these, x squared minus x squared is 0. And minus 4x minus x is minus 4x plus x, which is going to be -3x. So be careful there. I don't really need this next piece, but it's fine. What do you multiply by x to get -3x? Minus 3. And then we're done. Our slant asymptote, we should write it as y equal to x minus 3. So now we have all the information to graph this thing. I have, let's see, a y-intercept at -4, an x-intercept at +2, a vertical asymptote at +1. Seems like a lot of stuff is going on between 0 and 2 here. And then finally, the slant asymptote at y equals x minus 3. So y equals x minus 3, I'm going to draw it in green here. It should go through the point -3 for y and x equals +3. So it's going to do like this. Right, we don't actually have the point 3, 0, or 0, -3, but they are the intercepts of the slant asymptote. Okay. So now, if I start at my y-intercept, if we move towards the vertical asymptote, we have to go down this way. We can't go up because we can't cross the x-axis if we don't have an x-intercept. And then if we go instead to the left, we have to get closer and closer and closer to the slant asymptote. On the other side of this vertical asymptote, we're not down here, we're up here. And you can either find that by doing what we did, which was seeing that the vertical asymptote has an odd multiplicity, so it's going to switch, switch from up to down or down to up. Or you can plug in another point. Like you can plug in x equal to 3. And if you plug in 3 for x, you get 1 on top, you get 2 on the bottom, you get the point 1/2. You see, oh, it's positive. That means we're going to be above the x-axis, which means we know we have to be up this way. I suppose I should have really picked something between 1 and 2 because it could have changed signs, but we know it bounces there. So I was being kind of a little lackadaisical. It's going to come down this way. It's going to bounce at 2. And then it's going to get closer and closer and closer to the slant asymptote there. All right. That is the entirety of the fall 2019 practice midterm 2. I probably won't post these notes because the solutions are already posted. So I don't think I need to repost them again. There also is another practice midterm from winter. I don't remember if it's 2018, or 2020, which definitely if you're looking for more practice, I encourage you to do before you start your midterm 2. Please fill out the attendance form. Don't hesitate to email me if you have questions about the test or like something happens with the test. If something does happen, like you have trouble uploading it, there's internet issues, whatever, please email me as soon as you encounter issues so that I can help you with it. All right, that's all I got. Best of luck. And I'll see you all on Monday because we don't have class on Friday because I'm not going to be here. And you guys don't have class tomorrow because it's Veterans Day. So, but you do have your other classes on Friday. So go to your other classes on Friday. Stop sharing. I'm going to turn the video just for a moment. Thank you for the safe travels wishes. I appreciate it. I'm going to stop the recording.